this is the next derivation, and this derivation is about defining the Biot Savarts law uh, for magnetic fields. So the Biot Savarts law will define the Biot Savarts law mathematically, and this is for the magnetostatic fields. So when we are talking about magnetostatics, it's a magnetic field produced due to static electricity or DC currents. So suppose there is a if I am saying this, there's a conductor which is through which a current I is passing, and the length of the conductor is L, and this is obviously a closed circuit, as it might be connected somewhere to the battery and through which the current is passing. And if I am finding the magnetic field intensity, which is given by H at a point, if I am taking an infinitely small area of a dl length and I am finding the magnetic field intensity at a point which is located at a P. So this is a conductor which will be a wire or a metal which will conduct the electricity and through which current is flowing. Then there will be a effect which is known as the magnetic field intensity, which in this case will be in the direction inwards. So this magnetic field intensity can be given by the equation, which is dH is equal to the current which is flowing through the circuit or the infinitely small area will be IDL, that the current into length divided by 4 pi r square, that is the distance square, and the direction of this AR will be inward or it will be outward. So to find out the direction of this vector or the magnetic field intensity, suppose the current is you are considering a screw, and the screw is such that it is turned in the direction of the current. So the current is moving in this way, so if you are turning it in this way, then it will go inwards, and if the current is coming outwards, then you will be turning the screw in the anti-clockwise direction, and here you will be turning it in the clockwise direction. So whichever direction you are turning it, so the current is flowing in this direction, so the screw will be moving in this direction. So the direction of the magnetic field intensity will be inward. But in this case, when the current is opposite, then the right hand screw will have to be turned in the clockwise or the anti-clockwise direction, and in that case the direction of the current will be outward or coming out of the field, out of the point and going into the point. So this is the definition of what is known as magnetic field intensity, and if you see it with the analogy to the electric field intensity for a point charge, then the electric field intensity was given by k dq or divided by AR divided by R square. So the electric field or the magnetic field intensity is due to the current, while the electric field intensity is due to the charge. And to find out the magnetic field intensity due to the whole of the conductor, you will have to take the surface integral or the line integral, and when you are doing that, you will have to do the integration of IDL divided by 4 pi r square into AR. So this is what is known as the Biot Savarts law. And in the next lecture we will see the Ampere circuital law, and this will form the derivation of the fourth or the third Maxwell's third equation of Maxwell for static electricity.